Okay, so in this question we are asked to determine the ratio of sodium cyanide to hydrocyanic acid needed to prepare a pH 10 buffer, and we're given the Ka of hydrocyanic acid. Alright, so one thing to recognize first off is that this is a problem that will involve the Henderson Hasselbalch equation. Okay? And also remember that you don't need to memorize the Henderson Hasselbalch equation. You know, it's going to be on your equation sheet right there. Okay, so you can just use that, and that is this equation right here. So the pH of a buffer is equal to the pKa, okay, plus the log of the concentration of the base over the concentration of the acid in the buffer mixture. That's the Henderson Hasselbalch equation. So let's identify, we've got two components here, this one and this one. Which one is the base and which one is the acid? Well, the sodium cyanide, that's a soluble ionic compound, so when you put it in water, 100% of it is going to break apart into its component ions, and you're going to get sodium ions, aqueous, but the more important ion is the cyanide ion, aqueous, okay? And that's because that is your base. That's going to be the conjugate base of this weak acid. So this is a weak acid, and you know that because it's not on your memorized list of strong acids, and you know therefore that this part of sodium cyanide is the conjugate base. Okay? So at that point it's pretty much a plug and chug operation. So I know that I want the pH to be a 10, so I'll say, alright, 10.00, I'm going to substitute that in for the pH. And then you do need to remember the way to calculate a pKa. It's a negative log of the Ka when we're given the Ka. So it's negative log of 4.9 times 10 to the minus 10. Okay, plus the log of the concentration of the conjugate base, the cyanide, over the concentration of the weak acid, the hydrocyanic acid. Okay, oops. All right. So when you solve for the negative log of the Ka, what you get is 9.31. Plug that into your calculator and prove it to yourself. Okay, and so the difference when you subtract 9.31 from both sides, what you get over here is you get 0.69, and that's equal to this log of the concentration of the base over the concentration of the acid. Okay. And so the way to get rid of this log term and to turn it into this ratio of base over acid, remember you just raise this number, you raise 10 to the power of this number. This is an answer, which is an exponent on the base to give you this quantity right in there in the parentheses. So that concentration of sodium cyanide to hydrocyanic acid is equal to 10 raised to the power of 0.69. Okay, and so once again, if you plug that into your calculator, what you get is 4.9. And that's your answer.